Hi and welcome back to the channel. Today I'm going to talk about a new tool. The desk's a bit messy, sorry, it's the best I can do and show you everything, but hopefully you'll see what we're doing in a minute. Now, what we're talking about today is soldering, and in the past I've reviewed this, which is the Pinecell, the smart soldering iron. So you plug it into a USB-C cable and it warms up and you can set the temperature and everything else. And I have used this morning because I've tinned this small scrap of nickel silver. So I just put some flux on the nickel silver, and then spread some solder over it, just so it's got a very thin layer of solder on it. And that's because I want to talk about a different tool, which is this thing here, which is a London Road Models resistance soldering unit. So this works by passing electrical current through the parts to heat them up, melt solder, put things together. And the idea being that you can get heat to a very specific spot without having to use a normal soldering iron and getting a lot of heat everywhere. So it's very good for attaching small detail parts, and hopefully for laminating parts together as well, where you don't want to get lots of solder flowing all over the place and coming out around the edges, etc. So if you remember, the previous video we did, I talked about the fact that the next step in the build of the Peckett Gamecock locomotive was to solder a bunch of pieces together, laminate them together to give one of the mounts for the ball bearing race. I think I said it was a motor mount, it's actually for the one of the ball bearings. So I've been practicing before I get to trying to do that with some scrap. As I say, this is what I'm going to show you this morning. So what we've got here is this, it's basically, I think basically a computer power supply with a row of plug sockets on the front. And what you get with it is this strip of paper that tells you, depending on which of the sockets you put the cables in, gives you different voltages. So I'm using 2 volts. I've got the black wire and the red wire in those two holes, and that's all I need for this. I don't need anything more than 2 volts. And in some things I might be able to even step down to like 1.5 volts. But we're going to start with the 2 volts, and I'm going to show you how it works. So essentially we have the black ground lead, which currently doesn't have anything on the end of it. I need to get this a bit better, but basically that's the return lead. So I'm putting it under this metal plate that I've got here, so that it's nice and wedged down. So anything I touch that touches this metal plate with metal gives a return path. And what you have for actually doing the soldering is this probe. So it's a copper coated carbon rod, and I've just sharpened the end to give me a point. And the idea is that you put the 2 pieces you want to solder together down, you hold the probe down and you keep it held down, and then you press on a foot pedal, which obviously you can't see, it's out of shot. That sends the current through. You let go of the foot pedal after a few seconds, keep the probe in place while everything cools, and then lift off the probe. Now I've got this big piece of steel sheet, but it's a huge heat sink. So what I've actually got to make sure that I don't suck the heat away from the parts I'm wanting to solder is a piece of foil. That's attached to the metal plate with some magnets. That means that when I put the metal pieces that I want to solder on top of the foil and push down, there will be a path to the metal plate and hence the return lead, and there's a piece of cardboard under the foil that gives me insulation for the pieces. So I'm going to do it. So we've got the 2, as I say, there's one here that's been tinned. I've got another one that's no solder on it but was cleaned up. I'm going to put it on top. Now, because the heat is localized, I'm going to do a couple of spots, probably the center and then the 4 corners. So we'll see how that goes, and I'll count 1, 2, 3 while I've got my foot on the pedal so you can see what's going on. So you ready? 1, 2, 3, 4, 5, and let it off. If I've got this in the right place, you might actually be able to see the little light here coming on as well. Now I saw a little bit of solder come out the side of this, so I'm fairly certain that got hot enough. I'm going to hold it still, move my probe to a corner, and then do it again. So 1, 2, 3, 4, 5, let go. You saw the light come on that time. And then I will move around the 4 corners. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. And I think that should be done. Now I think I pressed a bit hard on that example, so I have left, I think, actually possibly some dents in the material. It's still quite hot. So let's get it off. It actually stuck to the foil in one place, which is unfortunate. I think that's because I'd actually had a bit of rubbish on the back of the part. But you can see that that is now nicely, if I show you, is now nicely stuck together. It's not coming apart. As I say, I might have dented the front, but let's clean it up a little bit. Let's just move this out of the way now. I'm just going to use a fiberglass brush. Hopefully you can see what I'm doing. Just to clean this up a bit, the surface, get rid of some of the marks. So yeah, I did push down a little too hard, and because it's thin silver, I've dented the plate slightly. Now, that's not normally a problem, because what you'd be doing is doing this from the back of the part, so you wouldn't actually damage the front. And as you can see, the other side that I had downwards is nice and shiny as well now. So let's just have another look at that now. So you can see all the black marks went away. But I have left a couple of unfortunate dents in the part. But you can see how easy that was, and how little work there was. There's no running this soldering iron, or you're soldering iron all over the surface, trying to get it all the way around the edge to seal it. I could probably, given that I got it to flash right from the very first press in the middle, because it was such a small part, I probably didn't need to work my way around the edges as much as I did. Yeah, that's the general. As I say, I've got a tiny little bit of solder that leaked out the edge here. Oh, that's the bit I saw flash as it went round. But these parts are not, not without a lot of effort, are not coming apart. They're nicely soldered together now, and I couldn't have done that quite so easily with my normal soldering iron. As I say, I need some more practice before I actually try it on the kit. I don't want to put dents like that in the kit. I need to be a bit more gentle. But you can see how easy it was. Just, can you put your foot on the pedal, and the heat's very localized. I need to, as I say, yeah, I need to be a bit more careful with my parts and not denting them, which I have done with these, because it's such thin brass. That's something to play around with. I did do another example where I didn't make quite so much of a dent. So this is 3 of the painting guides. You can see I used this one for the Allen Keith K12 kit. So these are full thickness etched sheets, and I laminated them together on this side, and they're not coming together, and there's 3 of these. I did have to go up to 2.5 for this, I think, just because I was struggling getting a good connection to start with, and cleaning them up, and it was the first thing. It wasn't the first thing I tried, it was the second thing I tried. This is the first thing I tried, if I can get it under the camera. So I just stuck a couple of bits of scrap etched together. There's one here and one here. This was the first one. As you see with the first one, I definitely burnt the surface. I'm not quite sure how I managed that. But again, it all went together really easily. And I'm really impressed. I've had this for probably a couple of years now. It's sat under my desk. I've not had the kind of opportunity or confidence to give it a try. I bought it not long after I'd built the Ivor the engine model. I will stick a link here, because I had problems with soldering together the boiler. So the boiler was a single piece that rolled round, and then you had to put a the face of the boiler on to close the front of the tube, and then that whole thing needed soldering to the chassis. And by the time you get to that, there's an awful lot of metal going on, and I couldn't get enough heat in with the soldering iron. It was just wicking away through the rest of the model, and I really struggled. In the end, I had to whip out the Cook's blowtorch to try and melt the solder and get the whole thing stuck together. And of course, once you start doing that, it's a lot less controllable, especially on a small 4mm scale model, and you end up with other bits unsticking, and especially with things like the boiler barrel, where it's trying to be wrapped tight and sealed, you start finding it's kind of popping open at the bottom. So I bought this. I had some money from some kits I'd made and things, so I reinvested it in more tooling. which was this. But as I say, I haven't had a chance to use it yet. So I'll put a link to London Road Models in the description. You can go have a look at their website. There is a bit of a wait usually on these. I had to wait 3 or 4 months, I think. Well, they do them in batches, I believe. And then they, when a batch is done, they go through the list of the people who have expressed interest. I'll also point out they're not cheap. I think this was about £250. But it's one of those tools that, if treated properly, will last an awful long time. I need to, as I say, sort out a better end. I can't just be sticking this under the metal plate, so what I need to do probably is drill a hole in the plate and a bolt that I can then have an eye and attach this onto, so it's not permanently attached. I did try just tack soldering it on, but I couldn't get the solder to stick to the steel plate, because the steel plate is so big, it's just such a heat sink, I can't get the solder hot. So I'll have to drill it, put a bolt through it, and do it that way. But that's okay. As I say, temporarily it's working just with the weight of the sheet. Holding the wire down is enough. So that's okay, but it's not ideal, especially because you have to be really careful, because if you've got your pedal down and you pull the probe off the surface, you can get arcing between the probe and the part or the plate, and so I don't want this to pop out from under here as I'm soldering something and it arc across. Not pleasant, and obviously it kind of wears out the carbon contact. But that's a replaceable part anyway. The carbon contact. This is just in a kind of standard kind of screw thread thing, and it comes out. So you can just put a replacement part in, or if you damage the nib on this one, you can just solder it. You can just sharpen it with a pencil sharpener until you get the point back, etc. And it works really nicely. So yeah, so that's the London Road Models resistance soldering unit. This is not the best demo or explanation for it. There is a brilliant video that I will put, if I can, I'll put a link to here. Obviously it's not my video, but I'll try and put a link here. If not, it'll be in the description, walking you through the whole kind of physics of how it works, what it's doing, and showing lots of examples of things like small parts, laminating parts, even using it to attach white metal parts, where you have to be careful because obviously there's an issue with the temperature of the solder and not melting the white metal, etc. But yeah, really good, really happy with it. Hopefully I'll be able to use it on the small run batch Gamecock kit with some good results, and hopefully this time, for the first time, I'll probably be able to successfully solder together some laminates for the kits. As I say, in the past I've often ended up resorting to super gluing them, especially for pieces that are visible. Internal pieces like the ball bearing mount, I may have in the past soldered and then cleaned up, but for laminates on the outside I've nearly always super glued, just because well, I just find it easier to clean up if I make a mess than the solder. But anyway, we shall see. But that's it for this week, and thanks for watching. Bye.